Hello everyone and welcome once again to this concluding interaction on chapter 4 quadratic equations class 10th. In this video we'll take exercise 4.4. So now see, till then we have discussed all the methods to solve the equations, and we rearranged some complex expressions into quadratic equations. Also we framed some equations from the given situations. So now in this exercise we'll first check the nature of the roots of the equation, then solve them. Also we'll see that whether the given conditions, given situations are possible. If they are possible, we'll check the same with the help of equations and the nature of their roots, and if possible we'll solve the equations formed from the situations. So let's begin. So question number 1 is, find the nature of the roots of the following quadratic equations. If the real root exists, find them. Nature of the roots is given by discriminant of the equation, that is b square minus 4ac. If the discriminant is either greater than 0 or equal to 0, in both the cases equation will have real roots and we'll find them. Okay, so first of all let's check the discriminant in this equation. B is minus 4 under 3, a is 3, and c is 4, right? On simplifying it, we get 48 minus 48, that is 0. 0 means equation will have two coincident roots, right? So let's solve them. Now see, if you are again free to choose your own method to solve the equation. In this case, since the numbers are smaller, quadratic formula is better option to solve such questions. So we apply the same, that is x is equal to minus b plus minus under root d upon 2a. Replacing the value of abc in the formula, we get this minus into minus 4 root 3 plus minus d, that is now see, d we have already solved here. Value of d we found here, it comes out to be 0, so we will replace this by 0 upon 2 into 3, that is 6. So finally we get x is equal to minus into minus plus 4 into under root 3 upon 6. Further simplifying it, we get the value of x as 2 under root 3 upon 3. So this is the coincident root for the given equation. Okay, let's take the second part rather. Right, 2x square minus 6x plus 3 is equal to 0. So let's check the nature of the roots first by the b square minus 4ac. b is minus 6, a is 2, and c is 3. On simplifying, we get 36 minus 24, that is 12. Means value of the discriminant is greater than 0, so it will have two distinct real roots, right? The equation will have two distinct real roots. Again, we'll solve with the help of this quadratic formula for the smaller terms, that is x is equal to minus b plus minus under root d upon 2a. That gives us, by replacing the value, that minus into minus 6 plus minus under root minus 6 square minus 4 into 2 into 3 upon 2 into 2, and simplifying gives us minus into minus plus 6 plus minus. So this discriminant is already simplified here, it comes out 12. So under 12 upon 4, this will give us two values of x, 6 plus minus 2 under root 3 upon 4. Now see, this 2 upon under root 2 into under root 3, how it comes out to be, means these are small things which uh, plays a major role in solving or calculations in mathematics. So will we apply laws of exponent in this? Under 12 first bifurcated or factorized into two. In out of two factors, one is complete square. In complete square, in this case 4 into 3, 4 under root 4 into under root 3, that comes out to 2 under root 3. So this is how under 12 is written as 2 under root 3, right? Now see, two values, that is 3 plus under root 3 upon 2 or 3 minus under root 3 upon 2. Now see how 6 is written as 3, 2 is missing, and 4 is 2. So 2 is common both from numerator and denominator. It will cancel out and we are left with these two values of x. right? So this is how we can suitably apply this quadratic formula for the smaller real numbers, smaller constant terms and all that, to avoid the lengthy calculations. Let's take one more. In second question, there are two parts. We have to find the value of k for which the equation will have two equal real roots. Okay. Now, for any equation to have two equal real roots or coincident roots, the value of d, that is b square minus 4ac, should be equal to 0. So first, let's see what is the equation. Equation is kx into x minus 2 plus 6 is equal to 0. First, we'll simplify it to get the quadratic equation in standard form. So on simplifying, we get kx square minus 2kx plus 6 is equal to 0, right? So here a is k, b is minus 2k, and c is 6. We'll replace this abc in this discriminant to get the value of k. Let's see how. B square minus 4ac is equal to 0 for two equal real roots. Replace the value of b by 2k minus 2k. A is k, c is 6. On simplifying, we get 4k square minus 24k is equal to 0. Dividing throughout by k and shifting 24 to this side, we are left with 4k square is equal to 24k. We'll now divide it by k to get 4k is equal to 24, or k is equal to 24 upon 4, that is 6. So value of k is 6 for this equation to have two equal real roots, right? So let's move further. Now see, we are given a condition and asked whether the condition is this situation is possible or not. If possible, we have to find the credentials given in the situation. The situation is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 square meters? If so, find its length and breadth. So first, let's put in these words into numbers and expressions. Let's see what we get. So length and breadth are in relation, that is length is twice its breadth. So let breadth is x, then length will be 2x, right? And area will be length into breadth, that is 800. On solving, we get 2x square minus 800 is equal to 0. Further, writing it in the form of standard quadratic equation. Now see here, b is 0, c is 800. Further, nature of the roots by d, if we want to find the nature of the root, then d comes out to be this, that is 6400, means d is greater than 0. Greater than 0 means nature means roots exist for the equation, right? Equation will have two real roots, or equation situation, this situation is possible, right? This type of rectangular mango grove is possible to design. So let's solve the equation now to get the length and the breadth of the mango grove. Again, we apply this b square, since b square minus 4 is here already, we have solved here. That comes out to 6,400. So we'll apply the formula here. Let's see what we get. Replacing b by 0, b square minus 4ac, it is already there, 6,400. 2 into a, that is 2 into 2, will give us plus minus under root 6,400 upon 4, right? That is plus minus 80 upon 4. So two values of x, either 80 upon 4 or minus 80 upon 4, which is either 20 or minus 20. Minus means negative is not possible for any length or breadth, right? So x means breadth is 20 meter. X is a 20 meter, breadth is 20 meter, and length is twice, that is 40 meter. Okay, so this is how the situation is first confirmed by equation and its discriminant nature of roots. Then we solved it by this quadratic formula, right? Let's take one more condition and check whether it's possible or not. So now it just like similar to previous one, is it possible to design a rectangular park of perimeter 80 meter and area 400 square meters? If so, find length and the breadth. So in this case, length and breadth are not in any sort of relation given to us. We are only given the perimeter and the area. So we will suppose, or we'll let the length and the breadth of the park L and B. The perimeter will be twice L plus B is equal to 80, or L plus B is equal to 40. From here we will write uh, B in terms of L, that is B is equal to 40 minus L, and we will replace this value here, right? Length into breadth, that is area is equal to 400 square meter. We will replace B by 40 minus L to get the quadratic equation. On simplifying it, we get the quadratic equation as L square minus 40L plus 400 is equal to 0. Now we'll check the nature of the roots. Okay, by D, that is B square minus 4AC. B square 40 minus 40 square minus 4, A is 1, C is minus 400. So it comes out to be 1600 minus 1600 is equal to 0. 0 means the equation have two equal real roots or coincident roots, means still the condition or this rectangular park is possible. So now let's find x. uh, let's find this x, sorry, in this case L by, here we are applying this splitting the middle term. We split this 40L into minus 20 minus 20 minus 20 minus 20 minus 40, right? When we multiply, we'll get plus 400. Follow the same procedure. L is common from first two terms within the bracket, L minus 20. From these two terms, minus 20 is taken out common. Within the bracket, we are left with L minus 20. Minus is already outside the bracket, so this plus is a minus, right? Then L minus 20 is common from this and this. So in second bracket, we are left with L from this, from here, and minus 20 from here. So L minus 20, L minus 20 is equal to 0. Now see, L is equal to 20. Coincident roots to equal real roots. So L is 20. Length of the park is equal to 20 meters. Breadth comes out to be 40 minus L, that is 20 meter also. So length and breadth are same for this park, right? Now you'll say that length and breadth when equal, it is a rectangular. Sorry, it is a square. Square is also a rectangle. When length and breadth are equal, rectangle becomes square. Okay. So let's see. So this concludes our chapter, quadratic equations. Now we'll quickly wrap up with by the key points, key takeaways from this chapter. What are the things we are supposed to learn from this chapter, right? So let's discuss one by one. First of all, that the standard form of quadratic equation is any expression that can be rearranged in this form, ax squared plus bx plus c is equal to 0, where abc is real number, right, and a is not equal to 0. Now take away is that a is not equal to 0. This is the condition. B and c can be 0, right? So if you come across an equation like 4x square is equal to 0, and you are asked whether it is a quadratic or not, so it is a quadratic equation. Remember this thing, right? Okay, now second point, factorization method, completing the square method, and quadratic formula for solving or finding the roots of the equation. Take away from this chapter, right? Factorization method is same as the splitting the middle term of quadratic polynomial to find its zeros, right? And nature of roots. Nature of roots is given by the discriminant, that is b square minus 4ac. If it is greater than 0 or equal to 0, then a real root exists. If it is less than 0, that the situation or the condition or the real root does not exist. Okay. Then we also learn how to frame equations from the given situations. We are given certain word problems and we have to frame equations first, then to solve them, right? And also out of the formula and completing the square method and factorization method, we see that quadratic formula is easy to apply, right? But in case of larger number, we should look for factorization method, okay? And also the major takeaway was that completing the square method is also cakewalk. It is not that complex or difficult as it seemed to be, right? So we also learn a trick for the same, this completing the square method. So these are few takeaways from this chapter, which will depend on person to person. Means what we learn depends on differently, right? So this is the chapter for you. Again, I'm leaving you with a small thought of inspiration and motivation that we should always, keep drilling and keep working hard for your goals, right? So wisdom doesn't come from speaking; it comes from listening. It doesn't come from knowing; it comes from seeking. Means if we know something that is better, good, but we should always strive to learn some new things in life. Okay. So with this thought, I'm leaving you here. We'll see you in next chapter, right? Thanks. Thank you for watching.